Alright guys, here's the exam 2 review that I promised. Um, in this one, I'm actually decided that I'm going to review all the questions, just in case if people feel like, okay, why didn't you cover the question that I made a mistake on? Okay, some of the easier ones I may just be pointing at the direction that you should be going, and for any that falls into the category of most mistaken problem, I'll try to explain them in details. Okay, so here we go. Now, question number 1 here. Well, first let's decide what kind of question it is. This is metal dropped into water and final temperature. So right there, you know this is insulated system. Okay, Q lost plus Q gain equal to 0. Okay, who's losing heat, who's gaining heat? Copper is hot, okay, is obviously losing heat. And water is cold, which is, of course, absorbing heat. Okay, well, we're looking for the final temperature. And the final temperature, of course, as you've already seen multiple times in examples in lecture and in recitation, final temperature of the two, since they're in the same system, should be equal. Okay, and there's nothing mentioning the cup or calorimeter, so we're actually only having two objects. So Q of the copper plus Q of the water should equal to 0. Now, for copper, we have Cm. This is joules mole degree Celsius. So NCm delta T, so turn your 220 grams into moles, and copper has 63.546 grams per 1 mole, and then 24.5 joules mole degree Celsius, and then times delta T, which is final temperature minus initial temperature of 218. And then for water, it's 200 milliliter and 1 grams per milliliter, so 200 grams, 4.184 joules gram degree Celsius, multiplied by the same final temperature minus the initial temperature of 25 degrees Celsius. And that total should equal to 0. So calculate out your number, extend your equation, put all the TFs on one side, a number on the other side, and do your calculation. You would find that your TF should equal to 27 degrees Celsius. So that would be your right answer. Okay, question number 2. Two thermochemical equations looking for a third Hess law. Okay, so how should I deal with it? Now, I have 7 nitrogen. I need to manipulate my known equation to match my target equation. I have 7 nitrogen, but there's nitrogen there, there's nitrogen there. Nitrogen in 2 equations, I don't want to deal with it. Water, 6 water. Okay, so I have 6 water in the known equation, 12 water in the target equation. In the known equation, water is on the right side. In target equation, water on the left side. So if we label them as 1 and 2, the first thing you need to do is that equation number 1, you need to reverse it. Okay, not only you need to reverse it, because reverse to put your 6 water on the left side, you need 12 water on the left side. You also need to double it. So you end up getting 12 water, 4 nitrogen, 6 O2, and 8 ammonia. Okay, and whatever you've done to the equation, you do to the delta H. So delta H need to be a negative sign now, and double that amount, so negative 2628 kilojoules. Now, all right, so that's water taken care of. The next thing, ammonia is already taken care of, and then NO2. I need 6 NO2 on the right side. I have 2 NO2 on the left side. So equation number 2 multiplied by 3. So you have 3N2, 6O2, 6NO2. And then 68 need to be timed by 3. So positive 204 kilojoules. Ooh. Okay, so add the two equations together, you get target equation. And that means add these two together, you should be getting your delta H, and the result of that, of course, is not negative 2628, sorry. So the result of that is negative 2424 kilojoules. B is your right answer. Now, formation equation. Honestly, I didn't expect this one. Ooh, what in the world is that? Damn it. Huh. Okay, so all right, let me erase these. All right, so I'm a little surprised by how many people missing question number 3. Okay, what is a valid formation equation? Okay, a formation equation is making 1 mole of a compound in its standard state from its elements in their standard state. So if you're not making 1 mole of compound, then you can cross it off. And if you're making 1 mole of compound and that compound is not in its standard state, what's water's standard state? Standard state, room temperature, okay, 1 atmosphere. What's water's standard state? What's the water state that you see every day? Not gas for sure. So 1 mole of making 1 mole of compound in its standard state, that alone eliminates 3 answers for you. Okay, and then from its elements in their standard state. Well, that's element in standard state. Is that an element? No, it's not. D is gone. Only choice that you got left, C. All right, now. Question number 4 is a quiz question. It's actually an identical quiz question. Okay. Now I'm gonna put the equation here. I'll put my calculation setup here. You have this many grams, and you turn it into moles. And then each 2 mole of N2 is going to produce negative 256 kilojoule of heat. Okay? Then you punch that into calculator. Now, the fact that this is a quiz question unchanged and even every answer choices choices is unchanged, and I still have more than 1/3 of the students missing this question is puzzling. Okay, now, are you working like you are supposed to? If you are, why? If you got this right, you have no reason to get it wrong now. It's the same question. If you got it wrong before in the quiz, why didn't you study your mistake? No. Okay, which of the following reaction will not happen? Okay, double displacement reaction will happen only when you make certain things. That's certain things that you cannot dissociate. If everything in a double displacement reaction can be dissociated, then you don't have a chemical reaction. Okay, so let's see. That's an acid, that's a base, you're gonna get water, so that definitely happens. Okay. Soluble, 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 soluble. Everything in here, according to our solubility rules, are soluble, so that's not going to happen. Just to make sure we have the one and only right answer. Now this gave me MgOH2. That there is insoluble. So that does happen. This one gave you iron acetate, which all acetates are soluble, but okay, let's move it here. You also get lead iodide. Solubility rule tells you that PbI2 is insoluble. You're making a precipitate, your reaction definitely happens. Yeah. This one gave you rubidium chlorate and cobalt sulfide. Anything containing rubidium or anything containing chlorate will be soluble. I don't even need to worry about that, but I'm getting cobalt sulfide. All sulfides are insoluble except when combined with group 1A and ammonium ions. Again, solubility rule, and that's insoluble. You can't dissociate it. This reaction would definitely happen. All right, next. Oh, by the way, these questions, I printed out a version, but since the questions are given to you in random order, so when you access it, you might need to look for which question is which. It might not be the same number from the ones that you see, that you did during the actual exam. All right, diluted. That's a dilution problem. Dilution problem is M1, V1, M2, V2, and you're looking for V2. So 20 milliliter or 0.020 liter times 1.8 molar should equal to X liter times 0.60 molar. And then you figure out the X. X ended up being 0.060 liter, which is 60 milliliter. You have no business losing the dilution problem. M1, V1, M2, V2. Doesn't get any easier than that. All right, grams making sodium hydroxide needed to make a solution. So I have 5.71 mole per liter. Okay, I have 240 milliliters, so 0.240 liter. That's going to give me mole of sodium hydroxide, and sodium hydroxide, you're even given the molar mass, each 40 grams NaOH per 1 mole NaOH. You're going to get grams. Okay, the calculation here should give you 54.8 grams. All right, so mixing 3 different ionic compounds. So let's see. you have positive ion, and positive ion. You have negative ion, and negative ion. Okay, so what are the possible products you could go? So, ammonia was originally with sulfate. Okay, now you can try it out with hydroxide and chloride. Neither of which would give you a precipitate. Ammonium ion is always soluble. Okay, yeah. And then strontium now can try sulfate or chloride. Chloride is not going to do anything, but with sulfate, strontium is one of the 6 ions: silver, lead, mercury, calcium, strontium, barium. One of the 6 ions that makes sulfate insoluble. So SrSO4 is definitely a precipitate. Then cobalt can have sulfate or hydroxide. Sulfate, cobalt is not one of those 6 ions, but hydroxides are insoluble except when combined with group 1A or calcium, strontium, barium. Okay, aside from those 8 ions, hydroxides are always insoluble. So cobalt hydroxide will be insoluble. So those are the 2, and that gave you answer A. All right. This next question here is one of our most mistaken problems in this exam. Okay, now, yes, it looks complicated with a lot of data. Okay, but we've done this type of stuff before. Reaction happen in calorimeter. Delta H plus Q equal to 0. Okay, now calorimeter doesn't absorb or release any heat, so, and you only have the solution, and solutions have density and Cp, so really you have 2 bodies, but since they have the same heat capacity, specific heat capacity, and same density, your final solution is only one solution body. So you really only, aside from delta H, you only have one sign. Okay, what about that delta H? We're used to calculate delta H, but this time you're given this. Okay, you're given a reaction. This is telling you that 2 moles of KOH or 1 mole of H2SO4 reacting with each other, you're getting this much heat released. Okay, so your delta H here should equal to, how many moles of potassium hydroxide or how many moles of H2SO4 you used. These 2 react with a 2-to-1 ratio, and if you notice, your concentration are the same, your volume are 2-to-1 ratio, so both of the 2 compounds completely react with each other. So it doesn't really matter which one you choose. Okay, if you choose KOH, this is 0.016 mole. Okay, if you choose H2SO4, it's 0.008 mole. Just molarity multiplied by volume in liters would give you that number. Okay, so it doesn't really matter which one you take. Now, each negative 113.2 times 10 to the third joule of heat is coming from, let's say I'm using H2SO4 because it's 1. Okay, so 1 mole of H2SO4. Okay, and I only used 0.00800 mole of it. Okay, I'm going to get, let me grab my calculator. So, negative 905.6 joules of heat. And this is how much heat for this particular reaction with this particular amount of reactants. Okay, and then this delta H, so negative 905.6 joules plus, okay, M is 16 plus 8, because 1 grams per milliliter means that's 16 grams, that's 8 grams. So times 4.184 joule gram degree Celsius and multiply by delta T. Okay, that equal to 0. That's a number. That's a number that can be calculated. You have only one unknown here, as in your delta T, or you can do it as T final minus 25. However you want to deal with that. Okay, but in this case, you find your delta T equal to 9 point. So let's make sure I have 905.6 divided by 24 divided by 4.184. 9.02 degrees Celsius, positive. So then plus the original 25 degrees Celsius, 34.0 degrees Celsius. Okay, so it's the same type of calculation we did with our calorimetry examples. Only this time the question is asked from a different direction. Instead of asking you delta H this time, we provided delta H and asked something else. All right, so oxidation number. Oxidation state. Now, fluorine is always -1, that makes carbon +4. Hydrogen is always +1 in compound, that makes carbon -4. Okay, hydrogen is +1. Oxygen is -2, that makes carbon +2. Okay, because 2 plus 1, that's +2, +2 +4, and then oxygen, you have 2 of them, each -2, so that's how you get a neutral molecule. Hydrogen is +1, that's +4, and that's shared by 2 carbon, so that gave you a carbon -2. And C60, well, you have one element all by itself, regardless of how many it is, oxidation number is 0. Okay? So, which one has the highest oxidation state? +4. That's your right answer. All right. Next page. This much heat is added into one piece of metal. Temperature change. Okay, so this is, and you're looking for CP. So this is a simple Q equal to mCp delta T type of question. And since you're looking at for CP, CP should equal to Q over m delta T. Q is 34.5 times 10 to the third joules. Your mass is 1.12 kilograms, so times 10 to the third gram. And your delta T is 93.45 minus 25.00 degrees Celsius. About as straightforward as it can be. 34.5 times 10 to the third divided by 1.12 times 10 to the third divide by 68.45, and the result is 0.450 joules gram degree Celsius. All right, reducing agent. Okay, so let's label our oxidation number. Chlorine is -1 monoatomic ion, oxygen is -2, which make your chromium +6, -2, which makes your chlorine +1, and that's +3. So chromium is going from +6 to +3. You gain electron. If you gain electron, you're going through reduction. If you're going through reduction, you're oxidizing agent. We're not looking for oxidizing agent, we're looking for reducing agent. Well, that leaves you pretty much the only possibility here. Okay, so think about it. -1 to +1, you have to lose electron, lose a couple of them. And as you lose electron, you're going through oxidation. And if you're going through oxidation, then you are the reducing agent. No problem. Cr negative is your reducing agent. Yeah. All right, so next. Balancing half reaction. Okay, so Cl2. Step number 1, identify half reaction. You already have half reaction. Step number 2, balance everything else except for oxygen and hydrogen. There's no hydrogen here. There's oxygen. I don't have to worry about it. So what's everything else? Chlorine. You have 2 chlorine here. You only have 1 chlorine here. You better put that 2 in. So many people are missing this question because they didn't put 2 in. And we specifically talked about this. We had example in your lecture, in your recitation like this. And if you're still missing on that, I don't know what else I can do. No. But putting that 2 in, that's going to give you 4 oxygen. So next step, balance oxygen with water, 4 water. And now don't just say, okay, I'm done. 4 water on the right. Okay? No. This is basic condition. With basic condition, now things change. 4 water, and that's 8H plus. And basic condition, what do you need to do? Oh, put in hydroxide on both sides to keep the balance. Now, these two get together, give me 8 water. Oh, I have 4 water there. I cancel that. Now what? Now you, element-wise, you're balanced. So how many water? 4 water. Which side? Left side. Okay. All right, for the in-person recitation, we talk about this next question. Okay, and for the online one, for the Zoom recitation, this on Friday, we didn't. Okay, so I'm going to talk about this one as well. 1 mole of compound dissociate 3 moles of ions. Well, let's see. That one dissolves 3 moles of Na and 1 mole of phosphate. Not going to work. 4 moles of ions. That one obviously dissolves. Both ions are soluble. Okay. 1 mole of ammonium, 1 mole of chlorate. 2 moles of ions. That one's gone. Lithium hydroxide. Okay. 1 mole of lithium, 1 mole of hydroxide. 2 moles of ions. That one's gone. Now, we're down to 3. Okay. Now, and then let's look at this one first. PbCl2. Okay, 1 positive ion, 2 negative ions, 3 moles of ions. That's my answer. 1 mole of the compound is added into water. It dissociates. What do you know about PbCl2? Solubility rule tells you your PbCl2 is insoluble. If it's insoluble, can you get 3 moles of ions? You can't even get 1 mole of ion. Okay? Ain't gonna happen. And that pretty much determines that your correct answer is D. But I also want to explain D. Well, this thing has 2 and 2. We specifically, go back to your solubility rule. We specifically talk about this ion in the solubility rules. I know I spent a good 3 minutes explaining things with this. This is not a regular metal cation. Okay, this is not a normal ionic compound because ionic compounds are not supposed to have 2-to-2 ratios. It's supposed to have the smallest whole number ratio. So what's with this 2-to-2 here? Hg2 2 plus is called mercury 1 ion. This is a polyatomic ion where the two mercury atoms are actually bonded together by covalent bond. To the outside, they show charge. So Hg2 2 plus is really like NH4 plus. Okay? It's a polyatomic ion. Yeah. And now, this ratio here is not a 2-to-2 ratio. This is a 1 polyatomic ion and 2 nitrate ion, 1-to-2 ratio. So when you put it in water, you're going to get Hg2 2 plus ion, and you're going to get 2 moles of nitrate ion. 1 mole, 2 mole, that's your 3 moles of ion. D is your correct answer. Okay, now number 15 here, or always a spectator ion. And I think I talked about this in all in-person and Zoom recitation. This question is not just about solubility rule. This is about double displacement reaction. Double displacement reaction involve molecular compounds. Okay? This guy has precipitate, so that's gone. This guy can make precipitate, that's gone. This guy can definitely make precipitate according to solubility rules, that's gone. NO2 negative and ClO3 negative, what's the difference? The only difference here, aside from both of them are in solubility rule number 2, but all solubility rules starts with the phrase ionic compounds containing. These guys also make acids, and those are not ionic compounds. It's not under the jurisdiction of solubility rules. Now, what's the difference between these guys? That's a weak acid. That's a strong acid. Which one is always going to be the spectator ion? It makes soluble salts and strong acid. So whatever it makes, you're required to dissociate it 100% anyway. And that's why this guy is always a spectator ion. And nitrite won't be because, well, what if your reaction involves HNO2? Okay? Now, I'll give you one right here. GNO2 soluble reacting with H2SO4 and GSO4 and 2HNO2. Soluble salt dissociate, strong acid dissociate, soluble salt dissociate, weak acid can't dissociate. Nitrite ion is definitely in the net ionic equation, in the ionic equation of this thing. Okay? But nitrite ion is not the spectator ion. Magnesium ion and sulfate ions are. Not always. Chlorate is the total of product minus total of reactant. Product is carbon dioxide, negative 393.5 plus 2 sulfate, so 2 sulfur dioxide, 2 negative 296.8. This is the total of the products minus reactant. CS2, 87.9 plus, oh, you didn't give me oxygen, free elements. Okay, oxidation number, standard heat of formation 0, and carry your calculation out, negative 107.5.0 kilojoules. which one will not happen? Fluorine is stronger than chlorine, is stronger than bromine, is stronger than iodine in their activity. Okay, so chlorine can go to bromide's house, and kick him out. That happens. Fluorine can go to iodide's house and kick him out. That happens. Bromine can go to iodide's house and kick him out. That happens. Fluorine can go to chloride's house and kick him out. And that happens. Can chlorine go to fluoride's house and kick fluorine out? Hell no. You're not even stronger as I am. How can you come to my house and kick me out? Not gonna happen? Correct choice. Yeah. Common ion. Both of the solutions contain nitrate. Yeah. And in the mixture, what is the total final concentration of nitrate? So nitrate from, let's say this is solution 1 and this is solution 2. So nitrate from 1 is 0.20 mole CuNO3, 2 liter of solution times 0.0125 liters. Each 1 mole of the compound, 2 moles of NO3. You get number of mole. Nitrate from 2, same deal. 0.64 mole of AlNO3, 3 liter, 0.0375 liter, 1 mole. Three mole. You get another number of mole of nitrate. Two numbers added together, divided by the 2 volume added together. And you would find that you ended up getting answer C. Yeah. Anybody using M1B1, M2B2 to do this next calculation, you're not studying right. You're not watching your video lecture right. This has been emphasized that you cannot, I don't want you to use M1V1, M2V2 for solution stoichiometry problems. Neutralize, chemical reaction happen. This is solution stoichiometry. Write your equation out. BaOH2, HNO3, I need 2 mole of that. Barium. Barium nitrate and water. 1:2 ratio. Okay, so you have number of mole, you have concentration 0.200 mole per liter HNO3 turns into mole cancel liter. Each 2 moles of HNO3 is needed for 1 mole of BaOH2. You get mole of BaOH2, you have a molarity, so that's 0.300 mole per 1 liter for BaOH2. that can cancel, mo can cancel, and you get your result. Okay, and you ended with 16 or 0.0160 liters, 16 milliliters. Okay. If you can't, last question, if you can't answer this one correctly, you're not paying attention going through your notes. 8 strong bases. First column of your periodic table: lithium, sodium, potassium, rubidium, cesium. All of them plus 1 charge, so 1 hydroxide, strong base. And then barium, strontium, calcium. Those are your 8 strong base list. Okay, and it's that obvious. Now, so review your problems. No, I'm not giving you the same questions on your quiz. Okay, so you better know how to do them, not just how to do that one. And question may be asked again from different direction. Okay, it's your call. You either spend time figuring out your problems, or you let that go. And that's it for the review video.